In this video, we'll see how to use exponents and division. We'll look at negative exponents first, and then dividing powers with the same base. So first, let's look for patterns with exponents. This will help us understand negative exponents. 3 to the 4th, right? That means that I'm going to use 3 as a factor 4 times. So 3 times 3 times 3 times 3, and this gives me 81. 3 to the 3rd, I'm using 3 as a factor 3 times, and that's 27. 3 squared, using 3 as a factor twice, that gives me 9. 3 to the 1st, I'm just using 3 once, that's 3. And 3 to the 0 is 1. So let's look at why that's 1 first off. We have that understood or implied 1 that's in front of everything that we look at. So really, when I say 3 to the 4th, it's like 1 times 4 3's, right? And 3 to the 3rd is 1 times 3 3's. 3 squared is 1 times 2 3's, and 3 to the 1st is 1 times 1 3. So when I look at 3 to the 0, that's just a 1 times no 3's. Not a 1 times 0, but a 1 times no 3, so that's 1. If I look at 3 to the negative 1, well, what does that negative do? The negative does not make this answer negative. What it does is it changes our multiplication to division. So really, 3 to the negative 1 is 1 divided by 3, or 1/3. 3 to the negative 2 is going to be a 1 divided by 3, which is 1/9. 3 to the negative 3rd is a 1 divided by 3, which is 1/27. And 3 to the negative 4th is 1 divided by 3, and divided by 3, 1/81st. Notice the symmetry here. 3 to the 4th is 81, 3 to the negative 4th, 1/81. 3 to the 3rd, 27, 3 to the negative 3rd, 1/27. And what we can do with that is we can look at a rule for negative exponents. A to the negative n power is equal to 1 over a to the n, as long as a is not 0. So let's see how we could use this. I want to write my answer as a fraction, so I can't have negative exponents here. So I have 4 to the negative 3rd. I want to rewrite it with positive exponents. I'm going to write it as a fraction, so it's just going to be 1 over 4 to the 3rd. I have 6 to the negative 4th. That's just going to be 1 over 6 to the 4th. And m to the negative 13 is going to be 1 over m to the 13th. All right, let's look at some other examples. Now I want to write my answer without the fraction bar, which means I could have some negative exponents, okay? So 1 over 6 to the 3rd, that's just going to be 6 to the negative 3rd. 1 over p to the 8th is just going to be p to the negative 8th. And there's a good phrase to remember to help you with this, and that is cross the line, change the sign. So if I cross the line of the fraction bar here, so if I had y to the negative 2nd or something like that, right? So if I cross this fraction bar line and make it, instead of y to the negative 2nd being in the numerator, if I put that in the denominator, I have to change the sign of the exponent. All right, now let's look at dividing powers with the same base. If I have h to the 5th and h squared, well, what does that really mean? It means 5 h's in the numerator, 2 h's in the denominator. And if I want to simplify this, well, I can just cancel out 2 h's in the numerator with 2 h's in the denominator, and that's h to the 3rd. If I have m to the 3rd, y to the 4th, over m to the 7th y, what does this mean? 3 m's in the numerator, 4 y's in the numerator, 7 m's in the denominator, and just 1 y in the denominator. Well, if we look at what is going to cancel out, 1, 2, 3 m's in the numerator, all the m's in the numerator cancel out, 1, 2, 3 m's in the denominator. And then my 1 y in the denominator will cancel out 1 y in the numerator. So I'm left with y to the 3rd over m to the 4th. And finally, let's look at p to the fifth over p to the fifth n squared. All of the p's are going to cancel out in the numerator, and all will cancel out in the denominator, leaving me with 1 over n squared. So we can look at some rules for dividing powers with the same base. What we're going to do is we're going to reduce the coefficients and subtract the exponents. So if I look at this example, 3m to the 7th over 12m to the 4th, well, 3/12, that reduces down to 1/4. And then I have the same base here, m in the numerator, m in the denominator, and I can just subtract. 7 minus 4, that's a positive 3. So let's look at some examples here. I want to simplify 2y to the 3rd over 8y to the 5th. 2 over 8, that simplifies to 1/4. Y to the 3rd over y to the 5th. I'm going to subtract these exponents. 3 minus 5 is a negative 2. That negative is telling me that my y is in the denominator. And then I just have 1 left over in the numerator. And next I want to rewrite without a fraction bar. So negative exponents are okay. So I've got my 3 here. M second, m to the 7th, 2 minus 7, m to the negative 5th. Okay? And then 8y to the 4th over 24y to the 7th. Well, let's just look at what happens if I simplify this. 8 over 24, that's 1/3. Y to the 4th, y to the 7th. 4 y's cancel out in the numerator. 4 y's cancel out in the denominator, leaving me with 3 y's in the denominator. But I don't want to have the fraction bar, right? So I need to push all of this stuff in the denominator up to the numerator. So this is going to become 3 to the negative 1 power, y to the negative 3rd. Those two are equivalent. Okay, I want to simplify these expressions, and I cannot have negative exponents in my answer. So the first one here, I have a negative exponent. I want to rewrite that. N to the negative 6, I could just write that as 1 over n to the 6. In number 2, I want to simplify this, and I don't want negative exponents. That means I'm going to may need a fraction bar here. 15 over 9, well, the coefficients just reduced to 5/3. G to the 3rd over g to the 5th. 3 minus 5 is negative 2, telling me that my variable g is going to be in the denominator. 12 over 8, that reduces to 3 over 2. And then m to the 3rd over m, subtract the exponents, and that's going to give me m squared in the numerator, b to the 4th, b to the 8th, 4 minus 8, negative 4, so b to the 4th in the denominator. And then let's take a look at this last one here. Notice the negative exponent in the denominator. 4 over 6 reduces to 2/3. And then m to the 2nd, m to the negative 4th. Well, what's 2 minus negative 4? It's really 2 plus 4, so it's m to the 6th. And that's how we work with exponents and division.